Okay then, today we will discuss about flip-flops. Mainly we have three type of flip-flops. One is SR flip-flop, second one JK flip-flop, third one D flip-flop. So let's discuss about SR flip-flop. In the case of SR flip-flop, it is also known with the other name SR latch. SR latch, and it is a simple flip-flop to use, very easy and convenient to use, and also it is known as the basic flip-flop. The basic flip-flop, it is called basic because by using the single flip-flop you can create all other flip-flops like D, JK and all. And also we can say that flip-flop is a bistable device. Bistable device. Just imagine the circuit with your normal switch cases. One case you can turn on the switch, the other one cases you can turn it off. Then two states, that is known as bistable device. Bistable device. Here you can see the diagram of SR flip-flop. In this diagram, we have two inputs, the input S and input R. In the case of input S, S stands for set. Input R means R stands for reset. Reset. If you are using set case, then your value will be 1. Set value will be 1. If you are resetting it, then your value will be 0. R or reset means your value will be 0. Then you can see the output portions here, Q and Q dash. Q and Q dash. And also we can call it like a Q naught, Q complement, everything. Just you have to notice that Q and Q naught, these are two opposite terms. If you are getting the output 1 in Q, that means Q dash will be 0. If you are getting Q dash as 1, Q will be 0. Then that is the difference between these two outputs. And it is the mark which is indicating that this portion indicate the input area. Input area. Then you can see the diagram here. In this diagram, we have two levels. In first level, we can have two AND gates. Two AND gates. And in the second level, we can have two NOR gates. You can recognize the NOR gate here. In the OR portion, we have a bubble here. That means it is NOR gate. NOR gate. So R is passed as input, S is passed as input, and also we can have one more value, that is clock. That is clock. In the case of clock, you can indicate it with the E, CLK, and also with the clock itself. Clock itself. So these three are our main inputs. But in the diagram you can see only two. Then why this? Actually this is your clock pulse. Clock pulse. Then the inputs are passing to AND gate, and after that it is moving to NOR gate, and inside the NOR gate we are taking the memory part of the previous portion. If we have done the previous circuits, then that memory consists of the previous circuits. We are taking the memory part or the previous state saved memory elements to this NOR gate, and we are forming a proper output. And what are the outputs available here? Q and Q dash. Q and Q dash. Then we can go to the detailed truth table. In this truth table, we can have three inputs here. One is S, R, and the other one is clock. Clock. We have three inputs here, and also we have two outputs here. As you can see, inputs means these portion, and outputs means Q and Q dash portion. So if we are passing two zeros, S is 0, R is 0, then you know that this is the starting stage of this circuit, so that we don't have any memory element already stored here. Memory is vacant here. Then you can see Q0 and Q0 as the output. Why it is Q0 and Q0? It is just indicating that both inputs are 0. Both inputs are 0 and it is not allowed in this truth table. That's why we are indicating this with Q0. Q0 means no change at all. Then in the second level we are passing two inputs, S is 0, R is 1. S is 0, R is 1. And we are standing in the second level, so we have a memory point which is solved in the first level. So we can use that memory level here, memory location here, and also the clock here. Then our outputs will be, at Q it will be 0, Q dash will give you the result 1. Q dash will give you the result 1. If Q dash is 1 and R is 1, then you will be staying in the reset condition. Reset condition. Then in the third level you can see S is 1 here and R is 0 here. We are using the clock pulse and also the previous memory. Then our output will be Q equal to 1, Q dash equal to 0. That means if Q and S is 1, then it is in the set condition. It is in the set condition. Then we can have the fourth level. We are giving the same values as inputs in both S and R, 1 and 1. Then we are using the memory space and also the clock pulse here. But our answer will be invalid here. Why it is invalid? We will never get any value like 1 or 0. We will never get a value like this. We will get some kind of errors. We will get some kind of errors. Just imagine that you are using any calculator, you are unendingly or finitely entering some values and doing some other operations without any proper condition. Then you will get a message like error. It may be syntax error or it may be simply error. That means some conditions are invalid for systems. System is never understanding the condition which you are providing. So that just imagine that a switch, can a switch will retain in both condition, switch in on and off, both condition place at one time? No, never. One condition it will on, other one it will off. We cannot place a switch in both conditions at the same time, so that our answer will be invalid here. So just simply saying SR flip-flop stands for set reset flip-flop. We can also have the inverted flip-flop with the name RS flip-flop, and with using SR flip-flop we can make the other two JK and D flip-flops, so that we can name it like a basic flip-flop, and also it is known with the other name SR latch. Then these all are our information regarding SR flip-flop. Here we can have D flip-flop. D flip-flop. Here D stands for data. Data flip-flop. So in this data flip-flop, we have our symbol here. In the symbol you can see two inputs are inputting here. What are they? D and E. D means the data itself. E means, E will be the clock pulse. The clock pulse. E or CLK is used to indicate the clock pulse. Then we are getting two outputs here. For the D input we can have Q output. For E, Q dash or Q complement. And we know these Q and Q complement will be inverted. Just Q will be invert of Q dash. and vice versa. Let us check the circuit diagram of D flip-flop. So we are passing the D here, data. It is going to a NAND gate and also to a NOT gate. And this NAND is taking another input. What is that? Clock. This clock is moving to this NAND and the D NOT is moving to this NAND and also the clock. So this is the first level of this circuit. And after that we have another NAND gate there. The next level, two NAND gates are there. In this NAND you can see one more input is there and it is the clock pulse and also the memory stored previous state. This is already similar to the previous diagram of SR flip-flop, and we can have the final answer like a Q and Q dash. Q and Q dash. Let us check all these points with the help of the truth table. So mainly we can say that D flip-flop is a simple flip-flop and only one input will be there in addition to the clock, and it is very useful when a single data bit like 0 or 1 will be passed to this input area and it is stored there. Then in the case of truth table, input values are like D and clock. D and clock. This incremental arrow mark is showing that the memory or the clock pulse is high here. Then the possible input for D will be 0 and 1. So if I am passing the 0 in D, then clock pulse is high here, and also in the case of output Q, it will be 0 and Q dash will be 1. Q dash will be 1. That means here we are storing a 0. We are storing a 0. And also it is the low input. Okay, then in this case, if our input is 0 and the clock is high, then Q will be Q and Q dash will be 1 here. And in this case we are storing a 0. We are storing a 0 and the state will be low here and the condition will be reset here because the storage of value is depends upon this 0. Then in the next session you can see I am inputting D1 and our clock is high here. Then Q output will be 1, Q dash output will be 0, and here we are storing a value 1. Storing a value 1. And also in this case our condition is high and the condition will be set here. Condition will be set here. So once again we are repeating the points, guys. In these D flip-flop case, it is very simple to use its operations also. Only one input in addition to the clock will be applied to this D flip-flop, and it is useful when a single data bit like 0 or 1. 0 or 1 is to be stored. Then how it is working? Working completely depending on the clock signal. You can see the clock signal here, and in these both 0 and 1 conditions clock is high here, so it is completely dependent upon the clock signal. When a clock signal is low, there will be no change in the output of the flip-flop. There will be no change in the output of the flip-flop. You can see both condition having high clock. There is no anything in low clock. And it remembers the previous state. That is the term with the clock. Here we can see the memory spaces we are using, so we can easily say that it is completely depending upon the clock and the memory. When the clock signal is high, like both of them is high, and if it receives any data on its data pin, like we are getting the input 0 or 1, we are getting any input in the data pin, it changes the state of output. So we have only these two state changes here. When the data is high, Q reset to 0. When the data is high, then Q reset to 0, and the Q is set to 0 if data is low. Data is low.